battery cell can perform beautifully in a laboratory and still fail as an aircraft program. Aviation needs thousands of cells to behave predictably after manufacturing, transport, assembly, vibration, temperature changes, charging, and years of service. That makes the factory part of the engineering. Every cell needs traceable materials, process conditions, inspection results, and test history, so an unexpected failure can be connected to a specific batch and cause. Small variation matters when cells are combined. A weak cell can limit a module. Uneven resistance creates heat differences. A damaged separator or contaminated process can hide until the pack is stressed. The aircraft battery adds structure, cooling, electrical isolation, monitoring, containment, disconnects, and software that estimates state and detects faults. Engineers then have to prove how the pack behaves during overcharge, internal failure, impact, water exposure, and thermal propagation without creating a new hazard for the aircraft. Scaling production changes the question. It is no longer, can one team build a good pack? It is, can the process build the same controlled pack repeatedly, document every deviation, and prevent an unapproved change from entering flight hardware? The companies that move fastest may not be those with the most dramatic cell claim. They may be the ones that turn chemistry into a stable, inspectable, certifiable manufacturing system.